all. You wanted to learn about pericentric, acentric, dicentric, paracentric, not in that order. So that's what we will be going over today. Inversions, week 9. I'm learning. Let's do this. This is our example chromosome we talked about. This is the normal one. This is the inverted one. I haven't drawn a centromere yet because we're going to talk about paracentric and pericentric. So, pericentric. Peri means around. Examples are perimeter. Paracentric means outside. Example, paranormal. Outside of normal. So, a pericentric chromosome is a pericentric inversion is an inversion that happens around a centromere. This is our example from today where we have our inversion here. It's flipped in this area and it includes the centromere. It's around the centromere. It flips around the centromere. Peri. For a paracentric inversion, that would be an inversion that happened outside of that would be an inversion where the centromere is outside of the inversion. So like between G and H. Our example is a pericentric inversion. And your questions were all about, of the produced gametes, what is viable? So, give me a second, and I will draw the inversion loop and resultant gametes. Ta-da! So, this is an inversion loop in the context of meiosis. This is how the tetrad looks when there's been an inversion. See how everything pairs up? Now, let's cross over. I'm going to cross over between C and D, right here. Yes. Like that. Yeah, it's totally visible. Okay, so then, there it is. So then, our resultant gametes go like this. One, the first gamete is there. One. It's going to go A, B, G, H. That's normal. I'll write them out in a second. I'll do the magic pause thing. 2. We're going to follow this one. A, B, but this is the inside chromatid, sister chromatid of the normal chromosome, the non-inverted chromosome, which means because it's the internal one, C, oh, here we go with our crossover. So we're going to follow that crossover to the next lane and follow it further, D, E, F, B, A. That's gamete number 2. I'm going to change colors for the gametes that are part of the inverted chromosome, from the inverted chromosome. This is for number 3. There it goes. For number 3, this is the inverted chromosome. It's the one that did not interface with the crossover. So it's gonna go like this, just the simple loop, and it's just gonna be the inverted normal thing. All of these have been accounted for. Moving to the other side, here is number 4. I'm gonna follow 4 like this. Crossover. It's gonna take that extra lane, and then all of our genes are accounted for. Ta-da! So, this is 1, 2, 3, and 4. 1, remember, was just the normal A, B, C, D, E, F, G, H. 2 was the normal that crossed over. So it's A, B, C, D, E, F, B, A. Which means that here, let's change colors. We have double A and B, and we're missing H and G. This is because of what genes are on the ends outside of our inversion. So for the chromosomes that were part of the crossover, each chromosome is going to have twice one end on the outside of the inversion and have none of the other end on the outside of the inversion. So this got double of this guy, and this got double of this guy, and doesn't have any of A and B. So 2, 1, and 3 have all of the genes necessary to make a baby, and they'll be fine. Those are viable gametes. But 2 and 4, 2 and 4, imbalanced genes. Inviable. 2 and 4 are inviable. And this is the answer to D in that question. They're inviable because the genes are imbalanced. They're inviable because they're missing things and they have too much of other things. So, given that, let's talk about para-centric inversions. As we remember, para was like paranormal, outside of normal. In a paracentric inversion, the centromere is outside of the inversion, like between A and B. So all of these letters still apply. We haven't changed anything. All of this is still accurate, but now our centromere is in a different place. It's here. So let's draw them in on our gametes. For 1, it's here. For 2, it's between A and B, wherever you find A and B. 2 has 2 copies of one end of outside of the inversion and none of the other end, and this end just happens to have a centromere in it, which means that 2 is dicentric. Dicentric. For 3, we have 1 centromere between A and B. For 4, genes A and B are missing. Therefore, its centromere is missing, and this is acentric. Di means 2, A means none. So this is still true. 2 and 4 are still imbalanced and inviable. but they're even more inviolable than they used to be because they can't do meiosis. They won't even get into gametes. Ta-da! So I believe that covered acentric, dicentric, paracentric, and pericentric. Post your questions. I will probably check the chat groups about once a day, casually while I'm doing other things, and I will respond to comments as I get to them. But please, if you see your group members posting a question and you know the answer to it, answer the question. Go ahead and contribute. I love the links that you guys have been sending. You have great questions. And to highlight some great questions, I pulled some fun ones. So one person asked, how can a chromosomal translocation be detected? So a chromosomal translocation means that a chunk of one chromosome has gone to another chromosome. And generally speaking, it would only be detected if it's a problem. So if it affects fertility, then that's one of the common causes for fertility problems. If you know that you have one in your family, you can PCR for it. Literally just search for a combination of genes that wouldn't normally be in a string together to see where that is. See whether that is now in a string together, and thus you have two bits of DNA that wouldn't normally be on the same chromosomes and next to each other, but they are here. That's in people. In worms, you can do, and flies, you can do mapping tests. You can check if it's on the same chromosome, if two genes are on the same chromosome that aren't normally on the same chromosome. And go ahead and tell me how you would do that. Jazz hands. So there's one. Another one is, what would it look like if, two or more chromosomal mutations happened at once, and what would that mean for the chromosome? I would love to see in the chat groups people coming up with entertaining weird combinations of chromosome mutations and what that would look like and how it would affect the fertility of the human whose DNA did this silly thing. So I give you this question as fodder to write in your groups because I need you to write in your groups. Everybody who has not written something in their discussion groups specifically, most of you have found the announcement. That's great, and I counted, if you responded to the announcement, I counted that towards your attendance for this week. But next week, I'm not gonna. Next week, I'm gonna make a discussion group, like this week's discussion group. And the attendance will be you posting within that discussion group. And I do want it to be on topic for the discussion group. It's going to be DNA, the anatomy of DNA, and transcription and translation is our next topic. So I look forward to hearing what you have to say in the discussion groups. So if you go onto Canvas and you see the groups icon in the far left bottom of your page, you click on that, it'll bring you to a group specific page. You're all in groups of 6 to 9, mostly 8. And there should be announcements and discussions. And if you click on discussions, you'll be able to see active discussions. You can also click on discussions in the panel on the left, and you'll be able to see all the discussions there too. So I look forward to continuing this adventure with you and hearing what you all have to say. Next week, there will be a brief lecture of things that I thought his lecture might not have been sufficient enough, so to fill in some gaps. And I'll also do a real quick video if there are common questions that I would like to address. So this week there's one video, next week there'll be 2 videos. The second video will be directly in response to your questions. So if you don't have very many questions, there won't be a second video. Please answer each other's questions, and you won't have to hear my face talking as much. Yeah, cheers, have a good one.